Okay, in this lecture, I'm going to go over how to complete the Word worksheet for the 3-1 dash, or sorry, 3-2-1 and 3-2-2. So I'm going to go through how to do that, and then also how to complete the Excel workbook for 3-2-1 and 3-2-2. So let's go ahead and get started. So I'm going to go ahead and share my screen here. Hmm. Okay. And so right now we're going to go home. Let's see here, and we're going to go to Unit 3 and go to 3-2-1, and we're going to download 3-2-1. Let's go ahead and open this up. Okay, so we've got 3-2-1, and when you're going through this, um, what it is that we do in Excel should be able to help you quite a bit. And so just I know that there is a tendency to maybe not do the work in Excel, but I would highly encourage you just go ahead and do that work in Excel because it's going to help you to um, be able to do this stuff a lot faster. I can actually do almost all of this uh, in just a few minutes, this entire worksheet in just a few minutes, just doing it all in Excel. So it's very powerful. Um, so you've got right up here, you've got some of the definitions, confidence interval, level of confidence. And so coming down here, if you use this, this right here is a chart or a Excel sheet, if you will. And if you were to actually go into Excel, I think that you could actually paste this. Yeah, you can. Um, and you could use this to calculate the standard error, the margin of error, the confidence levels, the confidence intervals, so on and so forth. We're not going to do that though. Well, we might. I'll just leave it there. So, coming down here, there's two scenarios when you would use a confidence interval, when you have the population standard deviation that's known and the population standard deviation that's unknown. And when you know the population standard deviation, you're going to use a z-score. When you do not know the population standard deviation, you're going to use a t-score. And so for this first worksheet, we are just using the z-scores. And then for the second worksheet, we are just using the t-scores. And so we've got a question right here. Um, yeah, let's go ahead and start with Lululemon. Lululemon is trying to determine how much customers spend on average. After sampling every 10th person that came into their store for a week, they determined that the mean amount spent was 232. The population standard deviation is 50, and 70 people were sampled. So I'm going to go ahead and use this fun little chart that I said that I wasn't going to use. And let's go ahead and put this information in. Okay. We've got uh okay. So first of all, what sampling method is used? This is the systematic sampling method. And if you go back to your previous work from chapter 1 or from unit 1, you can look at that and be like, okay, you've got every 10th person, that is systematic random sampling, every K person. And so you've got, let's see, what is the point estimate of the population mean? We're looking in here. And Lululemon determined that the average amount spent was $232. Okay, so we're going to do 232. And it's going to be the same for all these. Okay, and how many people were, let's see here. Oh, what's the standard error? We'll get to that in just a second. But in order to get the standard error, we have to know how many people were surveyed, and that's 70. And we'll just leave this at 70, 70. And then the standard deviation is 50. And now let's calculate the standard error. So the standard error is going to be equals 50 divided by the square root of the sample size. Okay, so we've got the standard error, which the standard error will be the same all the way down. Um, and now we are going to calculate the margin of error. Okay, so the margin of error is dependent on the z-score, which this is a little weird. I don't know why this is doing this weird thing where, let's see here. Alignment. Yeah, it just doesn't like it. I really don't know why. Um, but you've got the z-score multiplied by the standard deviation divided by the square root of n, or in other words, the z-score multiplied by the standard error. And so we've got the z-score, we've got 1.645 for 90%, we've got 1.96 for 95%, and 2.576 for 99%. And so we're going to do equals the z-score multiplied by the standard error. And so now we've got a margin of error when we're looking at 90% confidence. We've got a margin of error of 9.83. And if we just drag it down, we've got a margin of error with 95% confidence of 11.713. And we've got a margin of error for 99% confidence of 15.395. So what does this mean? This means that if I want to be 99% confident that the actual population mean um, is within a particular range, I might be off by $15.395. Or if I want to be 95% confident that this mean is accurate, I might be off, or the actual population mean might be off by anywhere in the range of 11.71 dollars, or $11.71. Um, and so and I really should have done this. Let's do lower and upper. Um, And so we've got the lower equals 232 minus margin of error. Then we've got the upper equals 232 plus the margin of error. And so we are just going to write this down. And what we can say then is we are blank percent confident that the uh, actual population mean is between $222 point 17 cents and $241 and 83 cents. Okay. Um so here it's 90% confident. Um and then here would be 95% confident. And then we can just drag it down. And we are 95% confident, and we are 99% confident that the actual population mean is between this and this. And so that's what we do over and over and over again. And so things don't really change. I can literally just copy this, drag it down, and it'll give me all the answers for pretty much everything. And the next thing that we're going to do also is calculate the margin of error percent. And so with the margin of error percent, we're going to do equals the margin of error value divided by the mean, and this will tell us the percent that we might be off by. And so it says, okay, we might be off by this percent. So it's 232 plus or minus 4.23%. And we can change this to a percent. There we go. And increase there we go. And so we've got the explanation, and we've got the upper, and we've got the lower margin of error value. And so if you look at our fun little sheet, we've got right here For Z, we use the 90% confidence. We use 1.645 for 95% confident, so we use 1.96, and then for 99% confident, we use 2.576. And so we have 90% margin of error value is going to be Z multiplied. So we did all that. 50 divided by the square root of 70, which gives you that. And so I did that right in here as well. And then I did it again, and I did it again. Or sorry, I did it right here. And then I did it again and again for the 90, 95, and 99. And so look at that. I just gave you all the answers. Um, and then at the 90% confidence level, between what two values can we expect the population mean to fall within? And boom, boom, right there. This is the lower value. This is the upper, lower, upper, lower, upper, lower, upper. And then the percentage margin of error, we just did this was you take this divided by the mean. And so all those answers are right there. And then um, we've got um, the interpretation right here. And so there's the margin of error percent, which is 232 plus or minus 4.24, and then the confidence interval, and then the margin of error value. So depending on the way that you interpret it, all three of these interpretations are correct. Um, and I mean, yeah, you can do any one of them and they're going to be correct. Normally I do the confidence interval because the confidence interval is the easiest to follow. And so you can adjust this you can adjust all these explanations to follow that. So, but let's go on to Aubon Pon. Aubon Pon is the restaurant that was in the business school before Rising Roll. And so we're going to do the same exact thing. And check this out. We're going to Control C. This is why you should use Excel. So X bar is going to change. The number is going to change. The standard deviation is going to change. But other than that, everything else can be done with formulas. Are you ready? So we have 40 sales. Okay. Oh, sorry. N is 40. And then we have the average amount is $4 for 25. And then the standard deviation is 1. And bada bing, bada boom, it does everything for you. So you just follow the same calculations over and over and over again. And not only that, because I put this fun little formula in there, it even gave me all of the correct answers for we are 90% confident that, we are 95% confident that, we are 99% confident that. And then if you change something, well, first we did at the 95% confidence level, we've got the value, we've got the percent, we've got the confidence interval. And so you come right over here, we've got at 95% confidence, we've got the margin of error value, the percent, and the lower and upper confidence interval. And then it's like, oh, change it to 90. Oh, we already did. It's right here. We've got 6.12%. The margin of error value is right there. And the lower and upper for the confidence interval are right there. And then if we were to change the sample size to 80 with a 95% confidence interval, not a big deal. We're just going to copy and paste it again. Okay. So sample size to 80. Okay. With 95% confidence. And so all the answers, we just have to look at those values right there, and we can interpret everything based on what we just did right there. And so I'm just trying to show you, first of all, how versatile this fun sheet is. This table that I gave you, it uh it literally goes through and how it gives you like a way to organize everything that you're doing. And so you can do this really quickly and easily. I don't expect you to know how to do this right here. This is using some more complex formulas. with putting text strings together with values and using nested functions. I don't expect you to know how to do that. I just did it because I wanted to show you, hey, it can literally be written out like this every single time. Um, and you don't have to, I mean, yeah, it's beneficial if you can say we are 90% confident that the actual population mean of amount spent at Aubon Pond is between, you know, 40 or $4.07 and 443, but not necessary. Not necessarily all the time. So, but once again, you can do the same thing, copy and paste. So let's copy and paste this again, Control C. And then we're changing it to 75 cents for the standard deviation. 0.75. And then just drag it down. And then it literally gives you all the answers. Oh, sample of 40. So yeah, sample of 40. Um, it gives you margin of error value, percent, confidence interval. Um, and so it gives you all those values as soon as you do that. And then please list the z-scores. You're a researcher looking at to find the average number of miles you choose to collect a sample. Please select the sample size you would like to collect, 40, 50, or 60. Um, and then from your sample, you find the average distance a student covers is 5.25, that the population standard deviation is 1.75. Select your desired level of confidence. These are things that the researcher can change. Calculate the confidence interval. Be ready to provide any of the following combinations for your quiz: value of margin of error, percent margin of error, confidence interval, an interpretation of any of the above three. So check this out. You're like, oh, that's a lot of work. Not really. Uh, so if we look at this and we say, okay, 5.25, and then bring that down, and we've got a standard deviation of 1.75. Okay. And then we do that how many times? 4 times. One, two, three, oops, 4. And then we just change the sample size. We've got 30, 40, 50, 60. Okay, so 30, 40, 50, 60. And I actually have all of the answers for this entire thing um already done in this one table. So this one table is all of the answers to the entire worksheet. Probably shouldn't have shown you all that, but you know, when you use Excel, you can do it very quickly. And let's see here. So now you've got everything broken up by question, so on and so forth. And so even if you want to, you can check all your answers, and know what's right and what's wrong. But yeah, you've got all the answers to all the questions, and all just because you were able to copy and paste and fill it all in. And we're going to look at how to do 3-2-1, with confidence interval around a mean. It's not that different than what we just did. So what we do is we look at the mean, standard deviation, sample size, so on and so forth. And so what we're going to do is we're going to get age. Um, and I should have just done this. Let's see. So sample size, it's going to be 101. Um, and then the mean age is going to be equals average. And I'm just going to calculate this really quick. Sample data, age. Oops. Equals standard deviation of a sample. Okay. And then the sampling error is going to be equals the sample mean minus the population mean. The standard error is going to be, let's see here, standard error, the standard deviation divided by the square root of the sample size. Okay, and then we've got the z calculated value. In other words, the z calculated of this sample size, or of this sample mean compared to this sample mean. And so what we're going to do is do equals the sampling error divided by the standard error. And that's with a z-calc, and then with the t-calc is going to be doing the exact same thing, but standard error with a sampling standard deviation instead. And so we're going to do equals sampling error divided by, and we're going to do the standard error really quick, with the sample standard deviation square root of, no, sorry, square root of 101. So your t-calc is a little bit different than your z-calc, and don't confuse these. Um, they're going to have different probabilities associated with them. And so when you calculate a t-calc as compared to a z-calc, it's a different distribution, and so you'll find what uh, you'll find that out just in a little bit. So coming right here, we've got the age, we've got the standard deviation, we've got the sample standard deviation, and now we're going to calculate the standard error. And so the standard error right here is going to be the standard deviation divided by the square root of n. So the standard deviation for the population divided by the square root of n. It did not like that. Oh, square root. Gosh, I just keep messing up. Okay. And then we've got the equals the standard deviation divided by the square root of the sample size. Okay. And then so the standard error is a little bit bigger here. Standard error is a little bit smaller here, and that's one of the reasons why that t-calc was smaller as compared to the z-calc, because the standard deviations or the standard error was larger here. In other words, the data is a little bit more spread out, a little bit more conservative with how spread out the data was. So use the known population standard deviation to find the margin of error. Okay, so what we're going to do here is we are going to do equals. Um, there's two ways that you can do this. You can follow these 5 steps. So do the z multiplied by the standard deviation divided by the square root of n, in other words, the standard error. And so you can do the z, so this is the z score, multiplied by the standard error. Okay. And then the other way, so that would give you the margin of error for the 90% confidence. The other way that you could do this, which you see it's 0.52, you can use this confidence dot norm, and then equals confidence dot norm, and then let's just do the 90% again. So 90% is 0.9 for the confidence or for the alpha, and then the standard deviation is going to be right here. And then the sample size is going to be 101, and then whoops, it's not 0.9, it's going to be 0.1. And when it gives you 0.1, it should line up perfectly. And notice what I did here is the z-scores 1.644. This is the actual exact z-score. This is the exact one for this, and then this is the exact one for 2.576. We just round it. And so if you get values that are just slightly off between the two, that might be the reason why. And so do that. So you could also do, confidence, whoops, dot norm, and then um, we have the standard deviation, sample size. So what is the standard deviation? It's that long one right there, but um, we're going to do 0.05, okay? And then we're going to do the same thing, but do 0.01. And then you see 0.8179, so this confidence.norm. But the other way that you can do it is once again equals the calculating the margin of error, the z-score right here, multiplied by the standard error, which is right there. And then um, do the same thing right here, equals the z-score multiplied by the standard error, and then equals the z-score multiplied by the standard error. And you notice they're the exact same, doesn't matter how you necessarily do it. But the z-score multiplied by the standard error is just as easy as doing the alpha, the standard deviation, and the square root of n, or and n. It just, yeah. Now with the sample, um, oh, before we do that, let's do, if you come down here, it'll be 95 percent, calculate the confidence interval with the standard deviation, or the population standard deviation known. And so I'm going to come right here and do lower limit and upper limit. And so what I'm going to do is equals the mean minus, it says for 95%, okay, equals the mean plus that. And so you can write, I am 95% confident that the actual population mean is between these two values. Or more specifically, I'm 95% confident that the actual population mean of individuals' ages is between these two values. And then if we were to do the t-value, there is a different way that you can do that with this formula right here. But to calculate the t, we're going to do equals, and you can come down here, t multiplied by the standard deviation divided by the square root of n. And so to calculate the t-score, uh, you can do equals t dot inverse dot 2t, and the probability is 0.1, and the degrees of freedom is going to be 101 minus 1 multiplied by, is that what I did wrong? I don't know. Okay. And so that's t dot inverse dot 2t, which this one might be a little bit easier to do the confidence dot t. So equals confidence dot t, and then do, once again, 0.1, the standard deviation is going to be right here. And then the sample size is 101, and it's the exact same thing. And so you can do that all the way down. You can do that for your Excel or for your Word document as well.